Scene 1, The Epidemic of Academic Garbage. Welcome to the 12th lecture of our wave mechanics series. Today, we address a raw, deeply uncomfortable truth that modern mainstream scientists desperately try to ignore: the fact that over 95% of published SCI journal papers are, quite literally, academic garbage. In Isaac Newton's era, scientists wrote papers to communicate hard-won, immutable truths. They would rather burn their manuscripts than publish an error. But today? Academia has morphed into a publish-or-perish cargo cult. High-impact journals have become paper factories, where researchers break their necks to publish papers they themselves know are useless, simply to secure funding and tenure. This is not a victimless crime. The refusal to retract wrong papers has poisoned the global scientific record, turning materials science and physics into a self-reinforcing swamp of errors. Today, we will expose several fatal errors published in prestigious, high-impact journals, and ask the ultimate question: why are editors and authors refusing to correct them? Scene 2, Exposing the Errors Part 1, The Carbon 2024 Scandal. Let us look at a concrete, shocking example of modern academic alchemy, a 2024 paper published in Carbon, a journal with an impact factor over 10. In this paper, Ho and co-authors claim that the relative permittivity, which is a fundamental, bulk material parameter, is actually a function of the thin film's thickness. Look at their figure 4. To anyone who has taken sophomore electromagnetics, this is a fatal, absolute error. Permittivity is independent of sample geometry and thickness by definition. Yet, when we submitted our formal critique, the journal rejected it. What was the reviewer's excuse? A reviewer actually wrote, "The first point cited is that permittivity is independent of thickness or geometry." However, this is not true from our experience on thin samples. Think about the sheer, unscientific absurdity of this statement. Because their flawed experimental setup produced miscalculated data, they threw out standard physics, declared permittivity to be thickness dependent, and the peer reviewers patted them on the back. This paper remains unretracted and heavily cited, polluting the literature. Scene 3, The Parade of Impedance Conflations. This is not an isolated incident. The literature is filled with papers that confuse the most basic concepts of wave mechanics. Take a 2024 paper by Saikia et al. In Applied Physics A. In their equations, they use the capital R to represent the film's reflection coefficient, but then swap it with the interface's reflection coefficient. They completely conflate the normalized input impedance of the film, Zin, with the characteristic impedance of the material, Zm. Or look at another 2024 paper in the same journal by Singh et al. In equation 9, they use a symbol for the film's reflection coefficient, while just one line above, the exact same symbol refers to the interface's reflection coefficient. They literally confused the two concepts within a single paragraph. Then we have Chemistry Select 2024 by Prima Hardianto et al. In equation 5, they use the interface reflection coefficient to characterize film microwave absorption. But basic energy conservation proves that while a film can absorb microwaves through internal propagation, a zero-thickness boundary interface itself cannot absorb energy. Conflating the boundary with the volume is a fundamental violation of physics. Scene 4, The Collapse of Wave Vector Mathematics. The errors run even deeper. To understand wave interference, one must understand that waves are vectors with both amplitude and phase. Yet, top papers completely disregard this. In a 2024 paper in Physica B by Andrianti et al., the authors define a first reflection loss and a second reflection loss in their figure 12. But reflection loss is a scalar power ratio, a unitless quantity of energy. It is not a vector. You cannot use reflection loss for wave superposition. You must use the reflection coefficient, which is a complex vector. This is the exact same blunder made by Wang et al. In their 2012 Journal of Applied Physics paper. They treated the superposition of multiple reflected beams as a sum of their independent energies, rather than a vector superposition of their wave fields. They literally tried to model interference without wave mechanics, treating waves as if they were billiard balls. Scene 5, The Penetration Myth and the Call for Scientific Retractions. In 2024, Abu Sanad and co-authors claimed in Physica Status Solidi, A, that ideal wave penetration requires the reflection coefficient at every boundary, R1, and are two to simultaneously vanish. But wave mechanics proves that the overall film reflection RL can equal zero even when individual boundary reflections are highly prominent, because the reflected beams cancel each other out in the air. When we tried to submit corrections, the editorial systems of these journals slammed their doors shut. Why? Because admitting these errors would mean admitting that the peer review system has failed. It would require retracting thousands of papers, collapsing the H-index of academic power brokers, and exposing the publish or perish game as a massive, metrics-driven scam. We must demand retractions for these papers. A retraction is not just for academic misconduct, it is the ultimate hygiene mechanism of science. If we do not purge these errors, we are teaching the next generation of students that consensus matters more than physics, and that citations matter more than truth. Our comprehensive critique, co-authored with Michael Drew and Ing Liu, has been published in Industrial and Engineering Chemistry Research in 2025. We have laid out every mathematical correction. We invite you to read the full papers on SSRN and KIOs, stand for scientific truth, and refuse to participate in the cargo cult of modern academic publishing. Thank you for watching.